Good morning, students. We have been learning about the Mendeleev's periodic table. Mendeleev had arranged elements in the increasing order of their atomic mass, but it was not successful. Mendeleev's periodic table cannot explain the position of isotopes. It cannot explain the position of certain elements in the periodic table, and he cannot predict the many elements which were present in the elements of higher masses. And that's why the fundamental basis, that is the atomic mass, was not considered accurate. And that's why Henry Moseley started his research in 1913. He was studying the structure of atom, and he found out that atomic number was the most important element of the fundamental property of the element. So what is atomic number? Yes, in class 9 we have learned what is atomic number. It is the number of protons in the atom of an element. Okay, so what is inside the atom? Atom has got a nucleus in the center. Nucleus contains protons and neutrons in it. Protons are positive particles and neutrons are neutral. So atomic mass of the atom is basically mass of protons and mass of neutrons. Okay, but nucleus is located very deeply inside the atom, and it does not take part in any of the chemical reactions. So there are some another particles called electrons, which are negatively charged particles, and they are rotating in certain orbits, energy levels around the nucleus, and these electrons are distributed in a particular manner, and the presence of these electrons is very important. Why? Because these electrons, which are present on the outer territory of the nucleus, take part in the chemical reactions, and that's why the physical and chemical properties of the element are quite changing according to the number of electrons present in these orbits, right? So that's why electrons play a very important role, and number of electrons is always equal to the number of protons, that is atomic number of the element. So that's why atomic number was taken as a basis for the classification in the modern periodic table. Okay, then when these elements were arranged according to the increasing atomic number, every element has got certain atomic number, that is number of protons. Every element has got fixed atomic number, and atomic number of one element is different from the atomic number of other elements, right? So when these elements were arranged according to the increasing order of their atomic number, it was found that there was certain repetition of properties, chemical properties, after certain interval of time. So this is called periodicity, repetition of chemical properties. Now let us take one example over here. Okay, this is lithium. Its atomic number is 3. Electron distribution is 2, 1. Next element is sodium. Its atomic number is 11. Its electronic configuration is 281. What is electronic configuration? It is the arrangement of electron in different shells. So sodium electronic configuration is 281. Similarly, potassium K, atomic number 19, has got electronic configuration 2881. Rubidium, atomic number 37, has got electronic configuration 281881. Caesium, atomic number 55, has got 28181881. Francium, 87, 281832 So in this manner we see that these elements have certain similarity in their electronic configuration. You can see here these elements have got one electron in their outermost orbit, and that means the valency of these elements is 1. So these elements, why they are grouped here together? Because they show similar chemical properties. So why this similarity in the chemical properties? You can see here in the structure electronic configuration, every element has got some similar structure of electron distribution. Okay, one electron. So in this manner, these electrons are taking part in the chemical reaction, and that's why this type of periodicity, that is repetition of the chemical properties, is occurring because of this type of electronic configuration. These elements which are grouped here are called alkali metals. They have one electron in their outermost orbit and they have similar chemical properties. Let us take some more example. These elements are called halogen: fluorine, chlorine, bromine, iodine. Right? So if you see the electronic configuration, fluorine atomic number 9, electronic configuration 27, chlorine 17, 287, bromine 35, 28, 18, 7, iodine atomic number 53. So how are the electrons distributed? 2, 8, 18, 18, 7. So again you can see here in this electronic configuration, all these elements have got 7 electron in their outermost orbit, and for stability these elements require 8 electron in their outermost orbit, right? So that means every element requires one more electron for the stable electronic configuration of the nearest noble gas. So that's why these all elements show similar chemical properties, right? So here we can see that electrons play a very atomic number, and electrons, arrangement of electrons, are playing a very important role in determining the chemical properties of the element, right? So that's why cause of periodicity in the properties of the element is due to this type of electronic configuration. So all these halogens have similar chemical properties because of the electron distribution in this particular manner. Now here you can see these 2, 8, 18, 18, 32. All these numbers are called magic numbers, because if the atom achieves this atomic number, this type of electron, then the atom becomes quite stable. So these are the completely filled shells. Okay, so these numbers are called magic numbers because they give stability to the elements.